Hi, this is Tom, and this is our third video for lesson 12. And I actually forgot there's one piece I need to show you. And let's try this. Let's simplify. Simplify the square root of, this is a big one, simplify the square root of 16 minus 7. Divide that by 31 minus 2 times 3. 3. Let's try that. Now, here's something interesting. Fractions. Fractions must first have simplified, have simplified numerators and denominators before other operations. And I'm also going to show you one more example of this. So let's try this. Here we go. So what I need to do is I need to simplify my numerator. Well, my numerator says I have subtraction 16 minus 7, that's 9. Over. Now, you can work on the numerator independently and the denominator. So you can work those at any pace until you get it just down to a single number. So now look at the denominator. It has multiplication in here also. So I first have to deal with the multiplication. That's 2 times 3, which is 6. Okay, so then my next step is I have the 9, and now I can deal with my subtraction. 31 minus 6, well, that is 25. Oh, and look at that. We did that fraction right up here. And we know the answer is 3/5. Now, I want to show you one more fraction problem that happens quite regularly. And that is this. Say I have the problem of 1 minus 2, divide that by 5. Now, I'm going to do it wrong. So I'm going to write this not equal sign. But if you have a moment, watch what happens. Or let's do it correct. Oh, you know what? We'll do it wrong. Let's do it right. I'm sorry. Sorry for my indecision. If I follow the directions up above, I first have to take the 1 minus the 2. Well, 1 minus 2, that's going to be a negative 1 divided by 5. That's, if I put that in the calculator, I can come up with a negative 0.2. Now, here let's be not correct. 1 minus 2 divided by 5. If I type this in the calculator, and here's what I see happening. If I type 1 minus 2 divide by 5, people forget what has to happen. Well, notice now that the first operation is not the subtraction, it becomes division. That's what our order of operations told us. So that means that I have to first take 2/5. So this, or 2 divided by 5, this becomes 1 minus 0.4. Well, if I subtract 0.4 from 1, I would be left with 0.6. So notice this is wrong. And it's because the calculator knows the order of operations quite well. So if you were to put this into your calculator of 1 minus 2 over 5, you have to tell it to first clean up the numerator. And so you do that using parentheses. 1 minus 2, parenthesis, divided by 5. And that would get you the correct answer in your calculator. Let's look at one more problem. And this is something we're going to see now quite a bit, and that is the use of formulas formulas and substitution. So for example, say I give you this formula. I give you the formula that C equals the square root of a squared plus b squared. And then I say evaluate this when, let's try this. How about when a is 3 and b is 5? What that means is that you replace the letters with the numbers. So when I rewrite this, I don't know C, so all I can do is write C. And then I copy it down. I still have my square root sign. But now, instead of an A, I have A is 3 from right there. So I would write 3 squared. And notice that I used parentheses. If you're in doubt, you should always use parentheses. Plus. And now here it says, we'll put in B, but what do we say B is? B is 5. So I'd put in 5, and I would square it. And so now I have 5 squared. So then we clean up inside of the square root first. We can't take the square root of 3 squared and the square root of 5 squared. First, we have to clean up all of this. It's kind of like a fraction, so we have to do cleanup first. Clean up first. Okay, so this becomes the square root of 3 squared, that's 9, plus the 5 squared, that's 25. If I add those two numbers together, that gives me the square root of 9 and 25, that is 34. And here's the interesting part, that is C. C is the square root of 34. If I wanted an approximate answer for that, I'd go to Good Grapher, find the square root of 34, and I would have 5.8. We'll round it to the hundredth, so 5.83. So this is 5.83. Now, there's one last thing you need to know, and that is this. If I ask you to say my variable is, or say I have a number of -4. If I give you a formula, maybe the formula is, and I say that this is x. X is -4. And I want you to evaluate what happens when x is squared. Well, remember up above here, I said that whenever you substitute, you need to use parentheses. So let's do that. -4 parenthesis squared. Well, -4 squared means -4 times -4, which gives me +16. Now, if I had done something else, if I had taken x squared, and I wrote this, -4 squared. Well, what happens here is the square isn't being applied to the negative. It's considered like a -1. And what would happen is you're actually going to end up with -16. So the parentheses are very important when you're dealing with substitution, especially the substitution of negative numbers. And if you don't believe this, watch. Let's go back to our Good Grapher. And let's do this. In parentheses, let's take -4 and we'll square it. And we get 16 like we thought. Now let's try this. Let's take a -4 and we'll square it, and let's see what we get. See, we get -16. So even Good Grapher knows the difference between whether you use parentheses or not. All right, we're going to stop there. And that is how you use the order of operations to simplify expressions and to utilize formulas. Hope this helps, and thanks for watching.